I welcome you all for this presentation. In this presentation, we are going to discuss about public key cryptography. We are just stepping into third unit. This is the overview of this presentation. Private key cryptography, public key cryptography, the difference between public key cryptography and private key cryptography. Then what are the requirements for public key cryptography, followed by security of public key cryptographic schemes. We all aware what is a private key cryptography, because so far we have discussed about the private key cryptography only, both classical cryptography as well as modern ciphers we have discussed. So this private key cryptography means it is also called as secret key cryptography, single key cryptography. Secret key means in private key cryptography both sender and receiver both are using a same key. So only single key, and it is a private key because only the sender as well as the receiver only knows the key. So it is called as traditional private, secret, single key cryptography and uses only one key. And it is shared by both sender and receiver. And if this key is disclosed, communications are compromised. And here it always symmetric. Symmetric in the sense parties are equal. Both sender and receiver is having the same key. So only it is symmetric. Hence does not protect sender from receiver forging a message and claiming is sent by the sender. This is about the private key cryptography. Some examples of private key cryptography in the sense beginner of cipher, then Hill cipher, Playfair cipher, then DES, AES, all those things we are using the private key cryptography concept only. Only one key is used, that is both sender and receiver. Encryption purpose as well as decryption purpose we are using only one key. That is the private key cryptography. Let us see what is a public key cryptography and what is the need for that. So it is probably the most significant advance in the 3000-year history of cryptography, and it uses two keys. In the public key cryptography, we are using two keys. One is called as a public key and another is a private key. So, and why the name it is public key cryptography? Because earlier a private key alone is there, then we have named as private key cryptography. Here we are having both public as well as private key, but we are just telling that it is a public key cryptography. Why the name? We have to ask the inventors of this cryptography only. So anyway, this is a public key cryptography which consists of two keys, public key and private key. Here asymmetric. Asymmetric in the sense parties are not equal. That is, one key is used to perform encryption process. The same related key is used for the decryption purpose. So both are not using the same key. Both sender and receiver are not using the same key. So only here it is asymmetric, parties are not equal. So it uses clever application of number theoretic concepts to function and complements rather than replaces the private key cryptography. And why this public key cryptography was designed? Actually, it was designed or invented by Whitefield Diffie and Martin Hellman at Stanford University in 1976. See how old was this cryptography concept? It was invented in 1976. So here they face some two issues, and in order to overcome those two issues only, they come up with this new cryptography concept, that is two key concept they have come up. So what are the issues they faced and how those issues are solved using public key cryptography? Let us see. So this public key cryptography was developed to address two key issues. One is the key distribution concept and another one is the digital signature. Key distribution means secret key. We are generating one key and the key has to be shared by both sender and the receiver. So while sharing the key, sometimes some intruders will come in and get the key, or many problems are there. So how to distribute the key in an efficient manner? So only Diffie and Hellman thought of coming up with this new method, that is both private and public keys are there. That is, each one of them have to generate two keys. One is their own public key. If I am a sender, I have to generate the public key as well as the private key, and my public key is shown to everyone, but private key is known to only myself. Likewise, the receiver also generated two keys. One is the public key and another is the private key, and the public key is known to everyone and private key is kept confidential by the receiver alone. So whoever wants to communicate or whoever wants to perform a communication or encryption at that time, I have to take the receiver's public key and I have to encrypt the plain text and I have to transmit that message. And whoever is having the related private key, so the receiver is having the related private key and the receiver is only able to decrypt the message. So I am performing the encryption process, but I am unable to decrypt the process. So only here it is asymmetric key cryptography. Asymmetric, both parties are not equal. I am performing the encryption process, but I am unable to perform decryption process. Why I am unable to perform decryption process means I am not having the key. Only the receiver is having the key. So only both parties are asymmetric. Both are not same. So here, in order to have this solve this key distribution problem, this public key cryptography was invented. Another thing is for digital signatures. That is how to verify a message comes intact from the client sender. I am signing a document, I am sending to you, and after some point of time, I am telling that no, I didn't sign that document. I am denying that I didn't sign the document. Then how to go about? So for that, in order to solve that also, this public key cryptography concept come into picture. So we will discuss later on how this public key cryptography is used in these for key distribution as well as digital signatures. Later on we will discuss. This presentation is just the introduction about public key cryptography. And here in the public key, two key or asymmetric key cryptography, we can have different names also, just like that of a private key cryptography. Here also we are having there instead of public key, private key cryptography, two key, one key. Here asymmetric, there it is symmetric. So here it involves two keys. One is a public key, so which may be known by anybody and can be used to encrypt messages and verify signatures. So it was mainly designed for the key distribution as well as digital signatures. So only this public key which may be known by anybody and can be used to encrypt messages and verify signatures. And we are having a related private key. This is very important, related private key. So once we are generating the key, we are having public key as well as private key. And public key is shown to the public and private keys get confidential. Whoever is generating, they only know that that particular person only knows that private key. So related private key known only to the recipient and it is used to decrypt messages and sign or create these signatures. So it is infeasible to determine the private key from the public key. And it is asymmetric because those who encrypt message or verify signatures cannot decrypt the messages or create the signatures. So this is the pictorial representation of public key cryptography. We are having a plain text, that is the input. And if you want to convert that plain text to the ciphertext, we need an encryption algorithm. Here the algorithm given is RSA because it is a public key cryptography algorithm. So RSA is there. See here, this is Bob's public key ring. So here Bob only. So Bob is generating two keys. One is a private and public key. And Bob's public key ring is known to everyone. Joy can see it, Mike can see it, Alice can see it, Ted can see it. Even myself also can see it. You also can see the public key of Bob. Likewise, Alice also generated two keys and the public key of Alice is also seen by everyone. So, if Bob wants to perform encryption process, what Bob has to do is, Bob has to get the public key of Alice, that is PUA, public key of Alice, Alice public key. That is taken and it is used in the encryption process. So we generated the ciphertext y equal to E of PUA is the public key of Alice, then the plain text. So we are using the RSA algorithm. There we are encrypting the plain text with the public key of Alice. Then the ciphertext is transmitted to Alice and there we are performing, Alice is performing the decryption. How Alice is performing the decryption? With the related private key, Alice private key. With that only it is possible to decrypt the message because it is encrypted using Alice public key. Similarly, if Alice want to send some message means to Bob means Alice has to take Bob's public key and Alice has to encrypt and send it. Like that, the same process continues. So each and every person, whoever is the sender and whoever is the receiver, both of them have two keys. One is the public key and another is the private key. Private key is always kept confidential with them. Public key is shown to everyone. So this is the difference between symmetric and asymmetric key or private key and public key cryptography. So conventional crypto system, what work we have to do is the same algorithm with the same key is used for encryption and decryption, and the sender and receiver must share the algorithm and the key. And in the public key cryptography, one algorithm is used for encryption and decryption with a pair of keys, one for encryption and one for decryption. And the sender and receiver must each have one of the matched pair of keys, not the same one. So in the security point of view, in conventional crypto system, the key must be kept secret. It must be impossible or at least impractical to decipher a message if no other information is available. And knowledge of the algorithm plus samples of the ciphertext must be insufficient to determine the key. So those things we are sharing it. Or as algorithm I am going to use. I know the ciphertext also, some part of the ciphertext also. Whether it is possible to find out the key? No. Encryption we performed using the key only, but how it is generated with the help of the private key only. So it is not here the same key only. In the conventional encryption process, same key is used. So knowledge of algorithm plus samples of ciphertext must be insufficient to determine the key. So the key is known to only sender and receiver. Coming to this part, in the public key crypto system, knowledge of algorithm plus one of the keys plus samples of ciphertext must be insufficient to determine the other key. So one of the key is known here, but with that key, we can't find out what is the private key. So it is very difficult because both the keys are generated by one person. So one key is related to another key. So whatever the key we are using for encryption, that key may not be used for decryption, but the related key is used for decryption purpose. So here one of the two keys must be kept secret, and it must be impossible or at least impractical to decipher a message if no other information is available. And this is the one block schematic of the public key crypto systems. That is, here encryption is performed using the private key of A. So if it is performed using private key of A, then the decryption is performed using public key of A. Here you see encryption is performed using public key of B. If it is performed, then decryption is performed using private key of A. Whatever we are doing in digital signature, the case is different, and encryption decryption it is different. So one key is used for one purpose, the related other key is used for the other purpose. So here we can classify this public key applications into three categories. One is to perform encryption decryption, that is provide secrecy, and another is to do the digital signatures, that is to provide authentication. Another is for the key exchange, that is session keys are generated and it is used. But not all algorithms are providing all the three procedure or all the three applications. We can't use all the algorithm. Some algorithm support for all the three cases, but some algorithm supports for the specific case only. So some algorithms are suitable for all users, others are specific to one. See here RSA, it is used for all encryption, digital signature as well as key exchange. Elliptic cryptography, that is also used for encryption, decryption, digital signature and key exchange. Diffie-Hellman, it is for key exchange alone. And digital signature standard. Later on we will discuss all the algorithms. Digital signature standard, it is used for only digital signature. So coming to the public key requirements, this public key algorithms rely on two keys. That is, it is computationally infeasible to find the decryption key knowing only the algorithm and the encryption key, and it is computationally easy to encrypt or decrypt the messages when the relevant key is known. So either of the two related keys can be used for encryption with the other used for decryption. So these are formidable requirements which only a few algorithms have satisfied. Likewise, we have seen, right, this Diffie-Hellman is used for only key exchange, but RSA is used for all the three purposes. Digital signature standard is used for only digital signatures. Elliptic curve is used for all the purpose. Likewise, the requirements are specific to a particular algorithm. Next is we need a trapdoor one-way function. First, we have to know what is a one-way function. That is y equal to f of x. It is easy to find. Generally, if you want to find, if you want to apply any value, that is here you mean that ciphertext equal to encryption of plain text. It is easy. But if you want to find out this plain text, that means if you want to extract the plain text without knowing the key, it is not feasible. That is f inverse of y, it is infeasible. So this is a one-way function. One way it is easy, the other way it is difficult. So only it is called as one-way function. So what is a trapdoor one-way function? So y equal to fk x or k of x. So it is easy if k and x are known. So if both are known, then whatever function we are going to use, then it is easy one. X equal to fk inverse of y, it is easy when if it is easy means k and y are known, then it is easy. But x equal to fk inverse of y is infeasible if y is known but k is not known. So this is called as trapdoor one-way function. One-way function is x equal to f inverse of y. Here, trapdoor one-way function means f inverse of f k inverse of y, that is k is not known. This is very, very important. So without knowing the key k, it is not practical to find out the plain text. So this is called as trapdoor one-way function. So a practical public key scheme depends on a suitable trapdoor one-way function. So this concept is only applied in this public key cryptographic schemes. So coming to the security of public key schemes, like private key schemes, brute force exhaustive search attack is always theoretically possible only. But here we are using the keys that are too large, that is greater than 512 bits. And mainly the security relies on large enough difference in difficulty between easy and hard problems. More generally, the hard problem is known but is made hard enough to impractical to break. So here most of the algorithms are vulnerable to attack only, but how much it is vulnerable and what extent it is vulnerable. So if the usage of this algorithm is over, then the cryptanalysts break the cipher means it's well and good, because most of the algorithms are vulnerable only, but at what percentage it is vulnerable. Whether our work is over, then it is broken by the cryptanalyst means it's okay. So only here mostly we are using very large prime numbers only, and prime numbers we are using, and it is also very large prime numbers we are mostly using for the key purpose. So here only we request the use of very large prime numbers. Hence, compared to the private key cryptography, this is slow. So it is slow compared to private key schemes. This public key cryptography is somewhat slow because we are using very large numbers, that is greater than 512 bits we are using. So in this presentation, we just discussed about introduction to public key cryptography. So we have seen the difference between public key cryptography and private key cryptography, and what is the need for public key cryptography, and what are the issues the public key cryptography can solve. All those things we have discussed. Then we have discussed about the public key requirements and security of public key schemes. Thank you.